So let's talk about angular and linear motion. This one is really interesting, and a lot of people never really think of this one, to be honest. But angular, it refers to the speed of your wheels. If you notice on your dashboard right here, as my little minion is doing, there's a little bar that says RPM, which is revolutions per minute. Since you have an automatic car, usually you don't read. You're not required to do. Some people prefer to read that, and in fact, some people need to read that in order to be able to shift gears. So let's talk about this problem. An interior crocodile alligator who drives a Chevrolet movie theater has wheels with 36-inch in diameter. Making a TikTok, he got pulled over by Cayman Island Police Department. He obtains a citation for traveling at 630 revolutions per minute. When he gets back to the water, he will have to explain what his speed was in miles per hour. He didn't care, he has a thick skin, but he will need to calculate it. Help this poor interior crocodile alligator calculate 630 revolutions per minute into miles per hour. So let's see what the problem is telling us. They're giving us a lot of information already. They're telling us that the wheels, ooh, whoopsie, they're telling us that the wheels have a diameter of 36 inches. So they are saying that the wheels have 36-inch in diameter. What other information do they tell us? They tell us that the crocodile is traveling at 630 revolutions per minute. We want to turn into miles per hour. So let's just write this down. So 36 inches in diameter, 630 revolutions per minute. All right, that means that in 1 minute the wheels will have turned 630 times. That is amazing. Well, if a wheel's turning 630 times per minute, how many times does it turn per hour? If you know how many times it turns per hour and stuff, then you can calculate the miles per hour. But keep in mind, each wheel, depending on what the diameter of the wheel, will have to spin different speeds in order to catch the same amount of distance. All right, so one is bigger, one is smaller. In calculus, I love to show that using what is called the chain rule. Different size of gears. If this one is spinning, well, this one needs to spin slower. If this one spins slower, that means that this one will spin this way. If this one is smaller, it will be spinning faster, depending on the size of this one. Will it depend on the size of this one? Which way is it gonna spin? If this one is spinning this way, that means that this one is gonna be spinning this way, which makes sense because this one is spinning that way, which means this spinning this way, so it can spin that way. Pretty nice. So that is revolutions per minute. So let's see. What is the process that we're gonna have to do? We're gonna have to start with, we know that there's 360 revolutions per 1 minute. We want to end up with something that says in miles per hour. Notice that the units are gonna be key in order to solve this problem. So more part of the process, since we know that the diameter is 36 inches, then that must be that the radius is 18 inches. And notice that we're going to need to know what the radius is because we need to understand what is a radian. We need to be able to switch somewhere from revolutions to minutes all the way to miles per hour, and radians are going to be part of that somewhere in there. The 18 inches of the thing is going to be part of that too. So let's start with this. We want to end up with miles per hour. And it's really simple. Don't let it overwhelm you. So the question is, we have 360 revolutions per 1 minute, and we want to achieve miles per hour. Can you think of any relation either on revolutions or in minutes that is associated with hours or miles? And the answer is yes. We know that there are 60 minutes in 1 hour. And notice what happens if we multiply this out. The minutes and the minutes will be gone, and now we only have 360 times 60 over 1. Now we still have revolutions and we still have hours. So which one do we want to start trying to eliminate? You already have hours where you want it. You don't want to switch the hours. So however, you do want to divide out that revolutions unit because the very last part does not have revolutions. So let's see, do we know anything else that has to do with revolutions in general? Anything that stands true for any wheel of any size? One revolution, all right, is equal to how many radians? Either you can talk in degrees, but this one we can do in radians. So we know that 2 pi around the entire circle of the wheel. All right, we're going from the motion of the wheel all the way to the motion of the speed in the road. All right, the linear. So we're going from a circle all the way to straight path. All right, we know that 2 pi radians is equal to 1 revolution. And now notice that the revolution units will be gone, and now we only have hours and radians on the top. So the radians, we want to convert it into something other than radians. So the only thing that we know is that the radius is 18 inches. Well, if we know that the radius is 18 inches, check this out. If this is 18 inches, let me rotate this one until this becomes 18 inches, and I just formed an entire radian. All right. And what do we know about the wheel then? Once it goes around, you form an entire revolution. All right. And we know that the measurement of this little radian is 18 inches. So we know that 18 inches is equal to 1 radian. And magically, look what happens. Ta-da! This is gone. But we're still not in miles per hour. All right. We need to do one more multiplication here. So we need to end up with miles per hour. So what do we know? We know that in 1 foot, there's actually 12 inches, right? Because we want to get rid of these inches. So we need to use that inches conversion. And now the inches are gone. But now I'm left with feet on the top. I don't want feet. I want miles. Do I know any? Remember this hour, we're not touching it. We're just skipping all the way into here. Feet, feet, feet. Anything that helps relate feet with miles. Well, the answer is yes. We know that 1 mile, which we wanted on the top, is equal to 5,280 feet. And if we convert this times is equal to 67. Oh, there's not more space. 67.47 miles per hour. That was the speed of Mr. Crocodile Alligator. 67.47 miles per hour. Da, 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 da. The last part that I want to talk about is nautical miles, and nautical miles are actually really, really useful. And what is a nautical mile? So remember, when you're traveling either through air or water across continents, it's not the same thing as walking, as traveling in a short distance. It's almost rectilinear motion, right? So you're actually traveling in a little sphere. So if this is the sphere of the world, right? What is a nautical mile? Well, we have this thing called the equator. All right. Well, on the equator, remember, we form a radian. 1 degree, 2 degrees, 3 degrees, 4, 5, all the way until we do the 360. All right. So what is a nautical mile? A nautical mile is 1 minute of 60. So remember, if this is the equator, so if this is the equator and we cut the equator into tiny little wedges of 1 minute, 2 minutes, 3 minutes, 4 minutes. How many minutes are around the equator? There's 60 minutes, right? So what is a nautical mile? A nautical mile is this distance on the equator, all right, of 1 minute. So what is 1 minute? All right, it is 1 mile, one nautical mile. So we're rarely going to be using these ones. In fact, you're not going to be assessing nautical miles. However, it is important to understand that those are two different ones. So we got the nautical mile versus the statute mile, which is the land mile that we're used to, the 50 to 80 feet. Right. So the really thing is one stat mile is equal to 0.1 stat mile is equal to 0.87 nautical miles. All right. And one nautical mile is equal to 1.15 statutory mile. It stays stationary, right? So if you notice, they're almost closely similar, but why is the nautical mile a little bit longer than the straight mile? Think about that. One land mile versus one nautical mile. I think this is really interesting. All right, well, that is all for this section.